Alright, so let's go over some geometric sequence and series questions. So let's take a look at the first example here. So it says, let k, 2k, and k plus 60 be consecutive terms of a sequence. Right? So for a here, we're going to find the value of k if the sequence is arithmetic. Right? So assuming the sequence is arithmetic, we're going to find the value of k. Right? So since it's arithmetic, to find the common difference, we know we are going to subtract consecutive terms. So if I take 2k minus k, it's going to equal the common difference. Or if I take k plus 60 minus 2k, it's going to equal the common difference, right? So now since both of these expressions equal d, the common difference, I can set them equal to each other. So I know 2k minus k is equal to k plus 60 minus 2k. So on the left here, that'll give us k. On the right here, we simplify, that'll give us negative k plus 60. Add k to the other side, we get 2k is equal to 60, so we know k is going to be 30. Okay? And then A2 says, write down the three terms of the sequence, right? And state the common difference. Okay, so A2. So the three terms. So the first term is going to be 30. The second term, 2 times 30 is 60, and the third term, 30 plus 60 gives us 90. So these are the three terms of the sequence, and our common difference, right, is equal to 30. All right. So that was the first part, all right, part A. All right, so let's take a look at part B. So we're going to find the value of k if the sequence is geometric, okay? Now, if the sequence is geometric, I know to find the common ratio, I divide consecutive terms. So if I take 2k and divide it by k, that's going to equal r, right? And if I take k plus 60 divided by 2k, that's also going to equal r. Now the k's divide each other out here. I know 2 is equal to r, so I can take k plus 60 divided by 2k, set it equal to 2. So basically I'm going to end up with k plus 60 is equal to 4k. So minus k on both sides, so I get 60 is equal to 3k, so k is going to equal 20. Okay? So now that k is 20, all right, so we found the value of k. It says write down the three terms of the sequence. All right, so the three terms of the sequence, so B2, so k is 20, so we have 20. 2 times 20 is 40, and then 60 plus 20 is 80, right? And then also the common ratio r is going to be 2. Okay? All right, so let's take a look at this next example here. So we're given this geometric sequence, okay? Part A says find the number of terms which are less than 100,000, all right? So for part A, we need to find the number of terms less than 100,000. So first of all, our r here, we divide 15 divided by 5, I know that gives me 3. So I know the common ratio is 3. So find the number of terms, right? So I'm going to use the nth term formula, and we know that we want it to be less than 100,000. All right, so the first term is 5, r is 3, and then we have to the n minus 1 power, okay? So from here, once you have this set up, this would typically be a GDC problem. So what you can do is, I recommend making the problem equal 0 first and then graphing it. So basically I would make it equal 0, and then I would have 5 times 3 to the n minus 1 power minus 100,000. All right, I think it's easier to find the solution this way because you just need to find the x-intercept after you graph it, right? So from here, we're going to open up the Inspire. All right, so let's graph our equation now. So basically all you need to do is graph the 5 times, we have 3, the exponent n minus 1, so use x for n, x minus 1, then we have minus 100,000. All right, so we're just going to graph this. And then typically we need to zoom out a few times maybe, so that we find the x-intercept. There's the x-intercept. So we only needed to zoom out one time, find the 0. So we know 10.015. Okay, so n is approximately 10.015. Okay, so it says find the number of terms which are less than 100,000. Okay, so when n is equal to 10.015, it's going to equal 100,000. So if you want less than 100,000, so we know we would round down in this case, 10, or n would equal 10. All right, and you really should verify just to make sure that this answer makes sense and that it's accurate. So plug 10 in here, right? So you would have 5 times 3 to the 10 minus 1, right? So that would be 9. And then double check this. If we double check this on the Inspire, we have, let me go to calculate, we have 5 times 3 exponent 9. We end up with 98,415, which is less than 100,000, which is what we want, right? And you notice if you had increased n by 1, so if you said n was 11, that means we would have 10 up here, right? So we have 10 up here. That would make it way more than 100,000. Okay, so we know that n equals 10 is the correct answer, right, for part A here. Part B says find the greatest term which is less than 100,000. So part B, to find the greatest term, we actually did this on the calculator already. That's when you plug in the n, which was 10, right? So we have 5 times 3 to the 10 minus 1, right? We put this in the calculator already to verify it. So that was when we got the 98,415, right? 98,415. All right, so this is the biggest term, which is less than 100,000. And then part C, find the greatest value of n such that the sum is less than 100,000, right? So we have 100,000 is equal to, and then we're going to use the sum formula, which would be 5 times r, which is 3 to the n power minus 1, all over 3 minus 1, right? And once again, I would do the same thing. I would set this equation equal to 0 and then graph it. Okay, so let's do that. Let's see, let's bring up the parentheses. So we have 5 times 3 to the n power. So use x there instead of n, minus 1. 3 minus 1 is 2 on the bottom. And then we set it equal to 0, so we would have subtracted that 100,000. All right, let's graph that. All right, and then we've got our x-intercept right there. So let's analyze the graph. 0. So we have 9.645. So n is approximately 9.645. Now remember, this is the value that would make it equal 100,000. So if we want to find the greatest value of n such that the sum would be less than 100,000, right? So you know n would be equal to 9, right? And once again, I would always recommend verifying this, right? So let's actually plug it into our equation right here with n equal 9 to make sure that it's going to be less than 100,000, okay? So let's go to calculate. So we have 5 times 3, then our exponent is going to be 9 minus 1, then 3 minus 1 is 2. So we end up with 49,205, right? Now if we increased n by 1, so let's say this right here, this exponent, if we increase it by 1 and it becomes 10, what should happen is this answer is going to be over 100,000, right? So now it's over 100,000, so we're correct, right, that our n must be 9. Okay? All right, so let's take a look at the next problem. All right, so we have this geometric sequence, right? Has first term u sub 1, common ratio r, find the values of u sub 1 and r, right? So I'll do this example A here. So we know that the seventh term is 3,645. That means 3,645 is going to equal whatever the first term is times r, and then we have n minus 1. So our n would be 7 since it's the seventh term, so this would be 6. Okay? And then also, this is the 10th term, so we would have 98,415 would equal the first term times r, and then you have n minus 1, so if n is 10, you would have 9 here. So basically, this is very common when it comes to sequence and series problems, where they want to give you two equations and you need to solve for a variable and then substitute. So typically what we want to do here is let's solve for u sub 1 over here. So we would get 3,645 divided by, all right, u sub 1, all right, actually, sorry, divided by r to the 6 would equals u sub 1, all right, divided by r to the 6 would equal u sub 1. And then what you want to do is we want to take this, right, we're going to substitute it over here for the u sub 1. So we would get 98,415 is equal to 3645 over r to the 6 times r to the 9th. So the r's simplify here, right? So basically we would end up with r to the 3rd. If you divide by 3645 on both sides, you would get 98,415 divided by 3645. Then we cube root both sides, and then our r, so put that in the calculator, cube root both sides, and then our r is going to turn out to be 3. Okay? So now that we know what r is, you can just plug it in here to solve for the first term. So we have 3645 divided by 3 to the 6th power. That would be the first term. So we just put that in the calculator, and then your first term is going to turn out to be 5. Okay? Now let's take a look at the next example. Let's do part C over here. So let's take a look at C. Okay? Let me erase this real quick. So part C, we're talking about the sums now. All right, we're talking about the sums. So if the sum, all right, of two terms is 20, all right, the sum of two terms is 20, right, what's going to be, and then we also have the sum of the 4 terms is 200. So let's set up these equations. So we know the sum of 2 terms, so 20 is equal to the first term, whatever that is, we don't know, right, times r, we don't know that either, right, but we know n would be 2, right, in this case, and then you would have r minus 1. And then the sum of 4 terms is 200. The sum of 4 terms is 200. So we've got 200 is equal to the first term times r to the 4 power minus 1 over r minus 1. All right. So now basically, kind of same idea. You want to solve for, I would say, u sub 1 here. So if you get u sub 1 by itself, you would have 20 times r minus 1, right, divided by r squared minus 1. That would equal u sub 1. And then what we're going to do is we're going to take this right here. We're going to substitute it for u sub 1 in this equation so that we get everything in terms of r. So once you do that, then you could just use the calculator to find out what r would be. Okay? So right here we have 200 would equal u sub 1, which is 20 times r minus 1 over r squared minus 1 times r to the 4th, right, minus 1, all over r minus 1. Right. Now remember, let me rewrite this real quick. So all of this equals 200. So what you want to do is you want to put this in the GDC to solve for r. Remember, this would be a GDC question, so don't try to start solving this by hand. Just graph it in the calculator so that you can find the r. Okay, so that's what we're going to do next. All right, so I've graphed this equation, right, and I've also set it equal to 0 already, right, and I graphed this equation, And then now I'm going to find the zeros. Alright, so analyze graph, find the zero. So it looks like it's going to be 3, and then the other one's going to be negative 3. Right, so R is going to be 3 or negative 3. So going back to our problem here, so I know that R is going to be 3 or negative 3. So I get some space, so R is going to be 3 or negative 3. Alright, so now next thing I want to do, so we found the R. The question also asks us to find, I believe, the first term. So now that we know what R is, we can plug it in right here to find the first term. So when R is equal to 3, we would have 20 times 3 minus 1 is 2, divided by 3 squared is 9 minus 1, which is 8. So we would end up with, let me see, 20 divided by 4, so we get 5. So when R equals 3, U sub 1 is equal to 5. And then when R is equal to negative 3, right, we would have 20 times negative 4 over 8. So this would give us a half, 10, so I believe negative 10. So when R is equal to negative 3, U sub 1, the first term, would equal negative 10. Okay? All right, let's take a look at this next problem here. So a geometric sequence has all positive terms. Okay, so it has all positive terms. The sum of the first two terms is 15, and the sum to infinity is 27. So we need to find the common ratio first. Okay, so first of all, let's take a look at the information we have. So if we know the sum of the first two terms is 15, the sum of the first two terms is equal to 15. So we can also write this as 15 is equal to the first term, which we don't know, plus the second term, which we don't know, but we can write it as the first term times whatever R is, because that would give us the second term, right? Now the sum to infinity, so the sum to infinity, they tell us is 27. So we can use the sum to infinity formula, which is 27 is going to equal the first term divided by 1 minus R. Okay? And then we have, well, we're going to have to do a substitution. So from this equation, first of all, I can factor out the first term. I would end up with 1 plus R. So 15 divided by 1 plus R is going to equal the first term. And then what I can do is I can substitute this over here now. So we get 27 is equal to 15 over 1 plus R divided by 1 minus R. Right? So this is going to be the equivalent to 15 over 1 plus R times 1 over 1 minus R. So I'm going to end up with 27 is equal to 15 over 1 minus R squared. Okay? And then now we need to solve for the R. So let me get some space. So we would get 27 times 1 minus R squared is equal to 15, right? And then we have 27 minus 27 R squared is equal to 15. So let's add R squared, 27 R squared to both sides, minus 15. That would give us 12. So then we divide by 27 now. So we're going to get 12 over 27 is equal to R squared, right? So 12 over 27, that reduces to what? 4 over 9. So when we square root both sides, R is going to equal plus or minus 2 over 3. Now they told us earlier that all the values are positive, so you know R cannot be a negative, the negative value. So we know R is going to be just positive 2 over 3, right? So we're going to reject the negative 2 over 3, okay? So we found the first part, all right, we found R is equal to 2 over 3. And then it says find the first term. So now that we know R is 2 over 3, we can find the first term just by plugging it into here. So we have 15 over 1 plus 2 over 3 is equal to the first term. So 1 plus 2 over 3, that's 1 2/3, or the same thing as 5 over 3. Right, so we have 15 divided by 5 over 3, which is the same thing as 15 times 3 over 5. So that would equal the first term. So it looks like we're going to end up with 9 as the first term. Okay.